partIII. partIII is all math. It's all algebra. What do we do here is we create yet another chart showing the two possible products that we're going to sell, Space Pirates and Battle Pacific, and how our decision would change based on would change if we change the data that we're given. That is, if competition happens at a different level. Okay, so this is the what if. What if competition is not as high as we thought? What if it's lower? What if it's higher? At what point, at what level of competition, Space Pirates is no longer the best option? Okay, this is something that you need to tell your manager, the decision maker. They need to know when to change course. Okay, so we're gonna create a chart like this. This is how you do it. You create a chart, looks like a box, right? And on the y-axis, you're going to have the expected values, and you get the expected values from all your nodes that you have here, right? All right, you're gonna get that from there. So that's the expected value. And then the horizontal axis, the x-axis, is going to be P, probability. And probability is going to go from 0 to 1, from 0 to 100. And this probability is the probability of competition. Okay, that's how we're defining it, because we are measuring the values of these two projects against competition. And we're going to change competition left and right. We're going to let it change from 0 to 100, from 100 to 0, and anywhere in between. And we're going to see how those two projects behave. All right, good. So Battle Pacific, this is the easiest to draw. It's a perfect line right across at 640. Why is that? Because Battle Pacific's expected value is 640. And back down, 640. You see that? And Battle Pacific faces no competition. There's nothing, competition will not alter the expected value for Battle Pacific. Therefore, as probability of competition goes up and down, the value of Battle Pacific stays fixed. That's why we draw a straight line across, right across. Okay, that's easy. Now, Space Pirates is a little more complicated. Space Pirates, if Space Pirates faces no competition at all, you will make 1,120. Where did I get that number? Well, no competition will be this branch, right? And if you don't get competition, you're going to get 1,120. You don't have to worry about demand now. Okay, it's already is built into this number. So without competition, 1,120. That point right there. Okay, so if I were to do this, let's see if this works. Right, if I'm drawing my chart here, I will pick, the first point will be there, 1,120, and this point down here, the 460, where did I get that point? That's the expected value of Space Pirates with perfect competition, with all the competition possible, which is 100%, right? Where do we get that? Oops, sorry, right here. With competition. So if we go down this branch and we face competition, it will be 460. So that's 460 right there. And then all I do is I just draw a line right through those 2 points. That's how I did it. This is not some fancy, this is not I thought I had the different components, but this is not something you select the ranges with Excel and then you go to your insert, charts. No. That's just me drawing lines. And you know how to draw lines. I show you already. Like this. Okay, that's how I did it. It's that simple. All right, this is the the junkyard. This is where I put all the crap that I don't need. Okay, good. Back here. So the question is, what do we need to know? Well, we need to know everything, but what we really need to know is at what point one is better than the other. At what point of competition one becomes the best option. In other words, this point right here, where they cross, that's what we need to find out. We need to figure out what's the probability at that point. And to do that, we're going to do something that you've done. I know you've done it back in high school many times. You probably just don't remember. It was probably not in this context, but you did it. You're going to take the equation of each of the lines and you're just going to make them equal to each other. Okay, so we're going to do a little bit of math here. Okay, so we're going to go here. All right, so Battle Pacific is simple because the equation of a line that is just flat across, it's just that line, it's just y equals 640. There's no x, it doesn't depend on, there's no p. It does not depend on probability. So it's just a flat line, 640. So that's the equation. This is the equation for Battle Pacific. Okay, let me get rid of that. Now, the other one is a little more complicated. Okay, now we need to figure out and build the equation for Space Pirates. To do that, we could go into all of the math, but just see, look at how I do it. It is quite simple the way I do it. Okay, you're going to take the y-intercept, 1,120. Okay, you're going to put it right there. Then you're going to do minus p, which is the probability, and then parenthesis, the y-intercept, the high y-intercept, minus the other intercept right here. You saw that, right? You're going to do this one minus this one, and that is 460. And that's exactly what I do right here in this equation. You see that? So 1,120, the y-intercept, minus p times 1,120 minus 460, close the parenthesis. That is going to be equal to Battle Pacific, which is 640. Now, the way, if you want to know more about how I did that, the long explanation, I actually posted it on our Blackboard, but it's also here, right? Where I actually find the slope, and that's what I did. I found the slope, and the reason why I have this little shortcut is because the run, which you remember the rise over the run, it's 1. Because the probabilities are going from 0 to 1. So that's why I can do the little shortcut and show you this little shortcut. This is how you're going to do it. This is how you're going to do it on the exam. This is how you're going to do it. Okay, this is how it works. It's that simple. Now, if you play around a little bit with all of this, you're going to end up with 660p equals 480 after you play around with all of that. Now, if you solve for p, you're going to get p, 480 divided by 660 equals 0.7273. That's it. That's that point. This point right here, this point right here, it's 73%, 0.7273. That's the probability at which if there's more than 72.73 probability of competition, if there is more, Battle Pacific will be the better choice. Because you see how Battle Pacific has a higher expected value than Space Pirates from 72.73 all the way to 100. That in that case, Battle Pacific, it's better. Okay, is better than Space Pirates. But if competition is below 72, 73, then Space Pirates has the higher value. That's the yellow is the value of the expected value of Space Pirates, and this is the value, right, of Battle Pacific. And as you can see, it's higher. So if competition is expected at 72% of the time, Battle Pacific is better. If competition is expected 72%, less than 72% of the time, 72.73, then Space Pirates is a better choice. Okay, and that's how. Well, imagine now you have all the data. You could inform your managers about all the different possible outcomes, when to change plans, etc. Okay, and that's it.